be online for the first time this semester. And I like to hear from you on what you like about the face-to-face class. You guys see me recording the lectures and things like that. So I guess what I want to hear from you, if you've had an online class before, maybe try to think through what you wouldn't want to lose in the face-to-face class that you want me to try to mimic for the online people. Or maybe tell me something that we could do away with, that really wouldn't be needed if it was an online course. If you've never had an online course before, then maybe just tell me something that is a pro about the face-to-face class or a con about the face-to-face class, so that then I can know to try to incorporate that element or not incorporate it. So like I said, we're still trying to make sure that it's a real quality course. We're looking at different ways that we can do the presentation of it. So I'm just wanting some feedback from you guys. Again, I'm going to want it to be a paragraph of your thoughts. So like I said, you can pick a pro or a con, a paragraph of your thoughts written in English, not text language. I'm reminding you that other students will be able to read what you posted. This discussion board will be open for 2 weeks. So it won't close until April 21st at 11:59 p.m. So all of that, you can read through all of it. When you get on Blackboard, you just hit discussions, and that's where it is. The first discussion board is already closed. This one is opening, and it should be open right now, but for some reason it isn't. So maybe Blackboard has a different clock in it or something. Questions or comments?
It's open.
Okay, okay, maybe it just looks, it's saying not available on my side, but okay, it's available to you. Thank you for checking that one. Other questions? Okay. Let me get the recorder going and then we'll get started on chapter 9 and 10. The way this author writes the book, they made chapter 9 and 10 be separate chapters, and usually they're in the same chapter with most authors. And he teaches it, or they present it, I should say, in kind of what I think is a choppy format. I'm going to try to stay with their format, just so that when you guys are writing your notes and you're trying to look through the book as we go, you can keep track of where I am. But what we might have to do then is kind of come back to some points I'm going to make in chapter 9 once we get into chapter 10, because they really truly complement each other. So when we look at chapter 9, starting out on page 308, they start talking about dollar returns and percentage returns, and it's very basic, and it's not to insult your intelligence, but it's just trying to set the stage then for thinking through in a simple format what we're talking about. So basically what they're saying is that, you know, kind of think through what it would look like if you, and I won't use their example, I'll just make up one. If you went and you put $100 into an account today, and at the end of the year you had $110 in that account, you would know that the first $100 was yours. Okay, so like the return of your investment. The $10 would be the return on your investment. So just kind of keeping that straight. That's all they're trying to have you guys review. Thinking about the return of and on your investment. And then looking at percentages. So the percentage would be that the $10 is a return on $100. And again, they're not trying to insult your intelligence. They're just trying to kind of get you in the mode where you remember kind of what's going on. Page 310, geographic mean return, don't worry about that. Page 312, the old version, page 300 if you're in the second version. Standard deviation. We're really not going to spend time relearning how to calculate standard deviation. You guys have already had to do that in your statistics class. So what we're going to do in this class then is go over to page 315, where what we're going to be looking at is a coefficient of variation. A coefficient of variation. And what that is that's your standard deviation. And they say it's divided by your average return. But just say it's divided by your return for right now. Because when we use we're going to be looking at standard deviations, and we'll be looking at expected returns. So just if you'll just know that it's divided by the return that we're talking about, then you don't have to worry about trying to come up with an average, because we're going to talk about that once we get into chapter 10. So coefficient of variation, okay, let's think about it. Standard deviation is a measure of how much movement you have in numbers. And the way that the author presents this is they make you try to think through movement in numbers as compared to the return that you would get. So movement in numbers, what they're trying to allude to here is the predictability of that movement, of those numbers. So they're pretending like the movement in the numbers that we see in the standard deviation, the way they present it, is that that's something that we can't predict. Okay, so we're not talking about movement in numbers in the example of if we have a swimming pool company in Wichita, Kansas. Okay, if we have a swimming pool company in Wichita, Kansas, we know that during the winter months, we're probably not going to be selling a lot of swimming pools, digging a lot of swimming pools, and we're selling a lot of supplies. But when summer comes, our sales are going to increase, because that's when people, spring, summer, people want their pools. That's when they need supplies. That's when they need to get their pools going. So our sales are going to go up. Okay, so there's going to be a lot of movement, a lot of volatility in those numbers. But if we can predict those movements, then we don't have risk. Okay, remember the definition of risk was the probability of an unfavorable outcome. An unfavorable outcome, when you're trying to predict numbers, is that there's no predictability, that you can't figure it out. In business, your ability to predict your numbers is very important. Like I had alluded to one time when I was in the Fortune 500 arena for companies, our ability to predict our numbers, whether we had better results or worse results, was very important. Because if that fund manager showed up and we had had a totally fabulous month that we hadn't predicted, they would be wondering if we would really know what's going on, because would we miss the downside too? So predictability becomes important, whether it's just trying to figure out what's going on with your company and the movement of those numbers. So risk would be the probability that you wouldn't predict those numbers correctly. So what we're saying here then, back to this, is the standard deviation then, we're saying that's movement in numbers that might surprise us. So we're saying, okay, what would be the movement in the return compared to the return that we're getting? So the way the coefficient of variation works, and I'll just make up one instead of using theirs, because that way if you want to go back and look at their numbers, you can. But let's kind of start out simple. Let's have example A and example B. And these are two investments that I come to you with. And let's pretend like I tell you that both of them, again, I'm going to keep it simple, and it's going to be obvious. But let's pretend like I tell you that both of them have a 15% expected rate of return. So 15% return. If example A, if company A had a standard deviation of 20, and example B had a standard deviation of 5, doing those calculations, 20 divided by 15 with the percentages canceling out, company A would have the 20% divided by the 15%, or a 1.3333 coefficient of variation, whereas company B would have the 5% divided by 15%, the percents cancel out for 0.3 continuing, 0.333 continuing. Like I said, it's easy when the expected rates of return are the same. If I'm coming to you and I want you to buy either company A or company B, and I tell you my ability to predict these numbers, and I'm telling you that this one has a 20% issue, standard deviation, and this one has a 5% standard deviation, you would already know, since they both have the 15% expected rate of return, I'm better at guessing what's going to happen with B, right? I only have like a 5% error. Here I have a 20% error. So that's why I made this easy, where the expected rate of return is the same, so it would be so obvious, and then you could also see how the coefficient of variation is working. So what we're saying is, when there's more unpredictability, there's more risk. So the coefficient of variation is higher. Less standard deviation, less error in my predictability. Standard coefficient of variation then is less. So obviously, if I came to you with two different companies, both expecting a 15% rate of return, you would choose the one with the smaller coefficient of variation, if both of them were viable examples of something that you could buy. And we're going to talk about that in chapter 10, how you get there. That's why I don't like how they present this, but we just go with it. So in your notes, coefficient of variation is used to compare investments once you've deemed that they're viable, that you can invest in them. You choose the one with the smaller coefficient of variation. And like I said, it's not always this easy, because sometimes maybe you're expecting, a 20% return here, a 14% return here. You've got to compare apples to apples. How much risk am I taking for that additional return is basically what you're looking at. The more risk you take, the more return you require. The coefficient of variation is trying to put that on an even playing field then for you, comparing unpredictability in the numbers to that required, or expected at this point, rate of return. Okay, so for that concept, know how to calculate it, memorize standard deviation divided by return, and know that if I'm having you choose between two investments, you want the one that has the lower coefficient of variation. Okay, and this is kind of where he's skipping around. Let me start the recording again. The next topic that the author jumps to is on page 316, 317. And this is a concept, again, that's going to continue on into the next chapter. And so it's kind of weird that he's putting it in a portfolio context already, but let's talk about it and kind of set the stage. So what they're trying to present here, if you look at the equation they're showing you on page 317, they're saying total risk is equal to firm, that's a bad word, sorry, firm specific, don't talk too fast, Peggy. Okay, I had allergy meds today, and they're making me a little hyper. Okay, that risk, and market risk. I'm high-strung enough anyway without having allergy meds, probably, right? Okay, so they're saying that when you talk about risk, okay, so let's go back to some of our original conversations. We said that when you're investing, you can invest risk-free, right? So risk-free would be in treasury-type securities. So the return of and on our investment is pretty much guaranteed, because the federal government would raise taxes or do whatever they needed to. Okay, so if we leave the risk-free environment and we're taking risk then, what we're saying is that we're taking risk just by entering into the market. In other words, leaving the risk-free environment. Then what's also happening is there's risk that's going to be specific to the firm that we're investing in. Because what we said then was that when you look at different industries, when you look at different companies, they're going to carry their own risk. We talked about how some companies are AAA rated, they're pretty risk-free because they're really well established, they maybe don't have a lot of growth, they'll pay dividends, they just plug along, they're good, stable companies. As compared to maybe a startup company that they're just getting started, there's a lot of risk. They're trying to get their product even maybe recognized. One of the most risky industries that you can get in would be the pharmaceutical industry, because if you think about it, they spend a lot of time developing drugs, and then it has to be FDA approved, and then it has to get on the market, and then they have to hope that they're not one of those drugs that's being advertised where you can get into some kind of a claim because it caused death or whatever. Okay, remember how you see that advertised on TV where attorneys are trying to get everybody who ever took this medication. Okay, so pharmaceuticals are very risky. So extremes there. So then that's going to be specific to the industry and then specific to the firm. So when they're talking about that, they're saying, okay, so what's diversifiable? What's diversifiable in this equation? Well, remember, we left risk-free. So that world's over here. So we jump out of the risk-free world, we come over into the market. The only way to get rid of market risk is to jump back over here into risk-free. That's the only way to get rid of the market risk, get back over here in risk-free. So what's diversifiable is looking at the industries and or the firms then that you're going to invest in. That's what's diversifiable. And we're going to learn an equation in chapter 10 that kind of helps us with that. So now he goes into this portfolio example where, and again, it's kind of weird that he's telling you this right now, but he's going to show you how to calculate then a portfolio return, and that's on page 324. And just let me make up a portfolio. Again, because you have that example in your book, so you can use that one. So here's one for your notes. So let's pretend like we invest in Company A, Company B, and Company C. Let's pretend like we've got $10,000 invested in Company A, $10,000 in Company B, and $80,000 in Company C. So our total portfolio is $100,000. Okay, if I wanted to look up then and try to figure out what my portfolio return was going to be, let's pretend like A is going to return 10%, B is going to return 5%, and C is going to return 20%. I'm just making up numbers. That's what I'm expecting. So then if I was going to try to figure out what my portfolio was going to return overall, I can't just say 10 plus 5 plus 20 divided by 3, because I don't have the same amount of dollars invested in all of those. Because when I look at my portfolio, 80,000 of the 100,000 has a 20% return, so that's going to help my portfolio perform better. So what I'm going to have to do with portfolios, put this in your notes, you'll always get a weighted average of those returns. So huge, 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 huge. Whenever you're looking at portfolios, it's always going to be a weighted average. Star, highlight, whatever you do in your notes to make sure that that concept is very important. So to get a weighted average, I'm going to take the 10% return for Company A, and I'm going to take it times the 10,000 that I have invested in Company A divided by the 100,000 I have in my whole portfolio, or in this case 10%. So that equals 1%. For Company B, it's going to be the 5% times the fact that I've got 10,000 invested in Company B divided by, that should be 100,000 in my total portfolio. So again, another 10%. So I think that would be 0.5%, if I'm not wrong. I better do the math because who knows what I'm getting. Okay. Then the 20% for Company C would be taken times 80,000 divided by the 100,000, or 80% of my portfolio is invested in that. So 20 times 80% is 16%. So when I get the return back on my portfolio, I'm expecting a 17.5% return on this portfolio. It's a weighted average of all of the returns that I have in that portfolio. And I'm going to leave that on the board for now. But that's basically your chapter 9 then. And again, it's kind of skipping around. We'll come back to some of these concepts. Questions or comments so far? Okay. Chapter 10. In chapter 10, they start talking about expected rates of return. And I am just going to stick with the one that he has on page 342, just so that you guys can refer back to it. So example 10-1 on page 342. Again, we're talking about expected returns right now. Expected. So if somebody brings you an investment that they want you to consider, and they're talking about the returns they're expecting, one of the things you need to do is you need to talk to them about how they came up with this expected return. Because what we're doing here is we're saying that when we calculate expected returns, what we need to do first and foremost is we need to talk about what we expect the states of the economy to be. So economic state, here we're expecting, and I'm just going to abbreviate, a fast growth, a slow growth, a recession, or a depression. And I'm abbreviating them. They're on in your book on page 342, example 10-1. So they're saying, okay, we're expecting those 4 states of the economy. Okay, so just like you guys check the Weather Channel maybe when you're getting ready to, or your weather app when you're getting ready to come to WSU because we have to walk so far across campus, kind of need to know if it's going to rain, snow, blizzard, be windy, be hot, be cold, right? So you look and see what the percentage chance of rain is, grab an umbrella, right? Okay, I do it, maybe you don't. So with the states of the economy, we need to know the probabilities, just like when we're walking across WSU, we need to know the probability of rain. So we're saying there's a 15% chance of a fast growth economy, 60% chance of a slow growth economy, 20% chance of a recession, 5% chance of a depression. So we're allowing for 100% or 1, the way this author did it. It totals 1, or 100% of what can occur in our economy. You're allowing for 100%. In this class, this will be given to you. We're not going to expect you to go and try to research what that would be. Okay, in this class, I'm going to give it to you. So then what you're going to say is, okay, expected return. So for investing in this company would be expected to have the return of 25% if the economy is fast growing. Okay? If the economy is slow growing, they're expecting a 15% return. If the economy hits a recession, they actually expect the company to lose 5%. And if the country or economy hits a depression, they're expecting the company to lose 20%. So the probability of the outcome versus the return. So once again, with expected returns, we can't just add these returns and divide by 4 because look, slow growth, 60% chance of that has more weight than a depression because there's only a 5% chance of that. So once again, we need to get a weighted average of those outcomes. So did he give me those numbers? Yeah, he did. So he's saying, okay, 15% chance of a 25% return is 3.75. 60% chance times the 15% return, that's 9. 20% chance of losing 5% is a -1. Don't forget to carry that negative. And then depression, 5% chance of losing 20%, that also totals out to be -1. So you're taking the probability of the occurrence or the return times that occurrence or return in this case. Then once you get that column, you add it all together. So what we're saying is the expected rate of return for this company is 10.5%. So put in your notes, anytime you're trying to figure out an expected return, you need to do a weighted average. Stars, highlight, whatever you need to do. Weighted average. It's not a simple average. I can't just add those returns and divide it by 4 because slow growth has the strongest chance of happening. It's 60% of the weight. And one of the things I said is when you're talking about expected rates of return and somebody's bringing you an investment, you have to ask them, what do you mean by expected rate of return? Because a lot of times what people will do is they'll say, okay, there's a 60% chance of a 15% return. I expect a 15% return because that's the 60% chance. Okay, that's wrong. That isn't what you need to do. You need to get a weighted average of those expected returns because you don't know what's going to happen in the economy, just like you don't know what's going to happen in the weather for sure. There's a percent chance it could happen. Everybody okay so far? Okay, another new concept. So the next thing that you're going to see on the bottom of page 342 is they're saying, okay, required rate of return. So now we're switching gears to required rate of return versus expected. We're talking about required now. And they're saying it's the risk-free rate of return plus the risk premium. And then they go on page 347, and they say there's an equation for that. And we call it the SML equation, SML, which means security market line. Security market line. But it's also called the CAPM equation, CAPM. Because that's the capital asset pricing model. So security market line is also the capital asset pricing model. Security market line, capital asset pricing model. So basically what they're saying is the equation that we learn to evaluate securities, meaning if we're buying into the whole company by buying a stock or a bond, it can be the same equation that the company can use when they're buying capital assets. Okay, so we can use it for our securities, buying into the whole company, stocks or bonds, or when they are buying their capital assets, their machinery, their equipment, their buildings. So we can use the equation for both. he uses a little bit different notations than other authors use. They're saying, okay, risk-free is capital R sub F. And then he's saying add to that. B stands for beta. R sub M stands for market. And then minus the return that was risk-free again. So they're saying your SML equation, or CAPM, equals R sub F, your risk-free rate of return, and this is on page 347, plus beta, which is your B, times then in parentheses, market minus your risk-free. So let's do some scenarios. I'm going to come over here because I'm going to do several examples. So let's kind of work with this equation just kind of outside the book for a little bit. So let's pretend that I tell you that your risk-free rate of return is 4%. And I tell you that the return on the market is 10%. So when we talk about return on the market, we're talking about the return on the market as a whole. So if we wanted to develop, let's just call it the SML equation for now because we're talking about securities at this point. If we wanted to develop an SML equation for a risk-free rate of return at 4% and the market having a 10% rate of return, basically what we'd have then is our SML equation would be that our risk-free rate of return is 4% plus, I'll talk about beta here in a minute. So just put plus B and in parentheses 10% minus 4%. So our SML equation then would be 4% plus B and then in parentheses 10 minus 4%. So here's what's happening. If we did the math of this, then our SML equation would be 4 equals, the SML equation would be 4% plus beta times 6%, right? Because you do what's in the parentheses first. So my SML equation would be 4% plus beta times 6%. What's happening here is the market minus the risk-free is the return for your market premium. So sometimes that's written capital R with a little MP. So it's the return, it's your market premium. So in other words, if I'm going to invest risk-free, I get 4%. Okay, coming back up to the total risk up there. But if I'm going to invest and leave the risk-free rate of return, I need additional return. Because I'm taking additional risk. So that's why this plus sign is here. I'm leaving the risk-free rate of return, I need more return to pay me for taking that risk. Okay, go back to total risk. My market risk, up there on the top, that total risk equation, is market risk, in this case that's the 6%. Then beta is going to reflect the firm, the risk of the firm, as compared to the market as a whole. So let's do some scenarios. Let's pretend like we have a beta of 1. So we're saying that the company is as risky as the market as a whole. So then let's plug that into our SML equation. So what we're saying then with the SML equation is that 4% plus beta of 1 times 10% minus 4%, well, that's going to equal 4% plus 1 times 6%. So that's going to be 10%. beta of 1. That means they're as risky as the market as a whole, exactly 1, exact same risk. The required rate of return, let's go back to why we're using this. The required rate of return that I would want to invest in that company is 10%. Make sense? The required rate of return is 10%. So how does it work now? Okay, that's why I want to leave this up here. When you're evaluating whether you can invest in a company or not, the expected rate of return has to be greater than or equal to your required rate of return. When you're trying to determine if you're going to invest in a company, the expected rate of return has to be greater than or equal to the required rate of return. So let's just use what we just did here. So 10.75% was the expected rate of return on the company that the author gave us. So if somebody came to me and said the expected rate of return on this company is 10.5%, I would need to know how risky that company is. If that company is as risky as the market as a whole, and if this was my SML equation, if I had 4% risk-free, 10% market risk, required rate of return of 10%, then I could invest in that company. Because 10.75% is greater than or equal to 10%, so I can accept it, okay? I can accept that investment, and life is good. Okay, what would happen if the firm was twice as risky as the market as a whole? Or beta was a 2. Okay, let's plug that in. So my SML equation would be 4% plus 2 times 10 minus 4%, or 4% plus 2 times 6, 4 plus 12, so that's 16%. Would be my required rate of return. So just doing the algebra. So notice, beta of 2, double the risk in the marketplace. It didn't make my required rate of return 20. So 10 times 2 would be 20, right? Because that was the market as a whole. Because what we're saying is, beta is only impacting the market. Risk-free stands out here all by itself. So that's why the plus sign, and that's why the algebra is supporting the concept. So know your algebra and know your concept. We're saying you're either investing risk-free and getting 4%, or you're moving over into the market and you're getting market risk of 6%. And so beta, the riskiness of the company, impacts the market risk. So it's 2 times 6 for 12 plus risk-free. It's not 2 times 10 the market risk as a whole, the market as a whole. You don't deserve 20% rate of return. You only earn double the market, double the 6, add the risk-free. So if that was the case, 10.75% is not greater than or equal to my, I almost put 12, 16%. So had that firm that they gave us as an example in the book been twice as risky as the market as a whole, and if this was our SML equation, I would have to reject that investment because for the risk I'm taking, I would need 16% or better. It's only giving me 10.75. Let's run another scenario. If the company was half as risky as the market as a whole, it would have a beta of 0.5, half the risk. So then you'd have 4% plus 0.5 times 10 minus 4%, or 4% plus 0.5 times 6%, or 4% for 7%. Once again, I'm just showing you that because it shows that beta is only impacting that risk-free, excuse me, not impacting the risk-free, only impacting the market premium. So 7% would have been your required rate of return. So it's obvious. Okay, I don't need to come up here. 7%, you would have accepted it. When the author starts talking about beta, they talk about the concept of a negative beta, and they talk about the concept of -1. So that would be something that's moving exactly opposite of the market, 100%. That's theory only. That's only in academics. There is no product out there that's 100% opposite of the market. There are companies or company divisions that will move opposite of the market. Not 100%, but opposite. Let me give you an example. If let's use Goodyear Tire. And I'm looking at the economy and how people buy tires. When the economy is good, people can afford new tires. So if I'm Goodyear Tire and the economy is good, my new tire division is probably doing really great. But if the economy takes a downturn and people don't have a lot of money, they're losing their jobs, but they need different tires, chances are they might go buy some retreads. So then when the economy is down, so you're looking at, kind of downward in the economy, but that division performance is going up. So that would be something that you would say would work contra to the marketplace. Market's down, that division is up. So that's why some companies or some divisions of companies would have a negative because they're going to act and react opposite of the marketplace as a whole. Retread division wasn't doing as well when the economy was good, but retread division started doing really great once the economy took a downturn. So that's what they're talking about there.
Do you see negative beta more often in inferior goods than in normal goods?
Probably. Because that's when people would flock to like the dollar store more and things like that. Any other questions or comments?
Would risk-free ever be greater than market risk?
It could be. Not very often though, but it could. Risk-free usually is relying on treasury type securities, and they're almost zero right now. So, in fact, zero or negative, I don't know where, but that's weird. Okay, then on page 348, they talk about a portfolio beta. I'm not going to go through the whole calculation with you. Just know, up there I showed you in a portfolio that you need to get a weighted average. So a portfolio beta is going to be a weighted average of all the betas. So all we're just saying there is that if you pretended like instead of me giving you rates of return, I gave you betas for a portfolio, you could take the amount that you had invested in that investment compared to the total portfolio times the beta. So anytime you're trying to work with a portfolio and you're given returns or betas and you're trying to get a portfolio beta or portfolio return, do a weighted average. Then what they're trying to show you is if you wanted to go through then, you could use the SML equation, and the beta might not be just for one firm, it might be for your whole portfolio. So you could plug in your weighted average beta for your portfolio and get the required rate of return for your portfolio. I'm going to challenge you though, and you might not be ready to think about this, but I'm going to challenge you because what's going to happen is, let's pretend like, I'll make up a little portfolio. Let's just use this one. Let's pretend like this is a portfolio that I have in place. So let's pretend like I really do have company A, 10,000, company B, 10,000, company C, 80,000, company A, 10%, B, 5%, C, 20%. My expected return on my portfolio then is the 17.5%. Let's pretend like somebody comes to me and they say, hey, we've got an investment here, and you company, they have an expected return of 25%, that's way better than your portfolio is performing, you need to buy it. I would say, wait a minute. I need to know my required rate of return. Because you don't just buy something because it's performing better than what you already have. Each individual investment that you make has to stand alone on its own with the expected versus required rate of return first. Okay, so let's pretend like we had the SML equation that we had before. So we said 4% for the risk-free, and let's pretend like they told me that this had a beta of 4. I'm making it extreme, so I know it won't work out. So 6 times 4 is 24 plus 4. Hey, wait a minute. I needed a 28% return in order to buy this thing that you're telling me is only going to return 25%. So yeah, it looks better than my portfolio, but I can't buy it because expected is 25%. That's less than my required for that standalone investment, so I reject it. So no matter how something is performing compared to your portfolio, you don't buy it unless the standalone expected versus required passes the test first. Another thing they talk about is diversifying your portfolio. So let's pretend like company A was, and I'm just making up stuff, Apple. Let's pretend company B was Walmart. Let's pretend company C was Ford Motor Company. If you came to me and said you wanted me to buy stock in GM, well, for other reasons I might not want to, but that's another automotive company, right? So you can see that's not going to diversify my portfolio. So when you're talking about diversifying portfolio, it's really easy for people to think about diversifying into different industries. That's kind of easy, you know, not having everything in the same industry, because companies in the same industry are going to act and react to the marketplace the same. But what's even more important is to look at then the betas for all of the companies that you've invested in. If you went out, and this isn't true, but if I went out and I looked, and if Apple had a beta of 1.5, and Walmart had a beta of 1.5, and Ford had a beta of 1.5, I'm not diversified at all, am I? They're all going to act and react just the same as compared to the market as a whole. So what you really want to do when you diversify is you want to try to look at what betas you have. So if Apple had a beta of, I'm just making stuff up, so don't go look this up and tell me I'm wrong. I'm just making it up. If Apple had a beta of 1.5 and Walmart had a beta of 0.5 and Ford had a beta of 3, and I was going to try to buy something that would complement my portfolio, I wouldn't want to buy something with a beta of those betas. I wouldn't want another 1.5 or 0.5 or a 3, because otherwise whatever I'm buying is going to act and react to the market exactly like what I already have. So that's another challenge that they're just trying to have you think through where diversification really happens. Once you enter the market and you leave that risk-free, you're taking market risk. You can't get rid of it. All you can do is diversify it by investing in different industries, and more specifically, different industries that have different betas, so they're going to act and react differently. The only other part of the chapter that I think might be of interest to you would be behavioral finance, looking at page 355. And what that's saying is, even though people should be using all of these tools to make decisions, you might do a calculation like this and you're like, well, the required rate of return is 28, expected is 25, and then you find out that the market is just going crazy over this stock and everybody's buying it, and you're like, that doesn't make sense. Okay, that's behavioral finance. It's saying that there's some things out there that won't make sense. Because for some reason, everybody's on a bandwagon thinking that, you know, this is the stock, this is the industry, this is where it's good. But look what happened in the housing market. Everybody kept thinking houses would go up and up and up. People kept getting loans, things were going on, the banks were making bad decisions, and all of a sudden, the bubble popped. So with behavioral finance, if you see something like this and the market is going crazy over something that you think it shouldn't be, that might be a sign to you that there's a bubble that could be popping soon. That that's an industry that they're putting way too much confidence in, that they're overconfident, they're overpricing it, and it can't continue on that upward trend. So that might be a good time to sell and not buy into that type of behavior. That will get you through the homework for chapters 9 and 10. When we go over the homework, I think it'll be a good time to kind of establish then some of the concepts.
Is beta like a thing that you can just look up on Yahoo Finance, or is that sort of a thing that you have to do?
You can, where I always get it, I don't know if Yahoo Finance has it, I haven't ever used them. I use Value Line when I need to look up a beta. And Value Line is something in the electronic databases at WSU. So if you wanted to go look at it, you could go pull up the Value Line, you can pull up a company, and it has a lot of other data on there too, but it's got a beta.